Okay, so as I mentioned the other day, there are three main topics in calculus: limits, derivatives, and integrals. This is the first chunk of limits. The stuff we did in day 6 wasn't really calculus. It was just some slope calculations. Calculate the slope of a secant line, calculate the slope of a tangent line. Or not even calculate the slope of a tangent line, approximate the slope of the tangent line. Today we get into some real calculus with limits. Okay? So, what is, you're going to understand, you know what, I'm standing here the whole period. Sorry, I'm blocking this. Maybe not that close. Understand the concept of a limit. You're going to learn some new notation. Has anybody done limits before? Did you do it last year in pre-calc at all? A little bit? Okay, good. We're going to guesstimate a limit. We're going to deal with limits around infinity. See what I did there? Infinity and beyond. It wasn't like it. Talk about some basic limits. We're going to plug and chug again. Plug and chug is very big in limits. And then one of your other goals for today is make a new friend. Here we go. Let's take a look at this graph. I got a basic x squared graph. You've all seen it before. It's so much cooler than here. Look at the point 1, 1. If you can't find it, it's the big blue dot. Imagine you're an itty-bitty person walking along that red curve. As you climb the hill, moving to the left, as you get closer to 1, what value do you get closer to? I'm standing in front of the air conditioner, so you need to speak loudly.
1.
1. Good. If I start over on the right-hand side and I start coming down the hill, heading towards 1, the x value of 1, what y value do I approach? 1. When I'm at 1, what y value am I at? 1. That's not rocket science. You're all with me, yes? Okay, those are the three conditions we're going to deal with.
Thank you.
Those are the three conditions we're going to deal with. What happens when you approach a number from the left? What happens when you approach the number from the right? And what's the value at the number? And each of those have different connotations. This one's simple. It's all the same. It's 1. But we'll look at some instances where they're not always the same. And that idea is going to be what a limit is. Okay, so here's the notation. I don't know why that's a 2. That should be a 1. What is the limit as x approaches, it's supposed to be 1, of x squared? And then the other two we talked about were these two. The blue one is, notice where the plus sign is, it's on the right-hand side of the number. That means, what is the value of the function as you get closer to 2, coming from the positive side or the right-hand side? The green one is the same idea, except we're approaching from the other side. From the left-hand side or from the negative side. Common mistake is people get the green notation confused with what happens when x approaches negative 2. It seems silly, but look at where the minus sign is. The green one means as you approach from the negative direction, the left. The other side would be the number negative 2. Okay. Now, sometimes we'll shorten the notation. We might just say the limit of the function f of x as x approaches some number. As you continue to do limit problems, every step of the problem you need to write the word limit with the notation. You can't just drop that notation out of the problem because you're too lazy to write it every step. It has to be included, especially on the AP test. They will not be happy with you if you just decide to drop it off for a couple steps. Okay. So, what's a limit? Well, we haven't really talked about what a limit is. We just talked about some values on a function of x squared. But let's take a look at this graph now. And we've got that point there. Looks like it's about 2.5, where there's a hole. So I'm going to ask the same questions I asked before. What's the value of the function as you approach 2.5 from the left. So, in other words, as I travel along the function, getting closer and closer to that value of 2.5, what's the y value? Now, that might cause a little bit of confusion, because if I go back to this guy, it's clear what value I'm approaching. As I get closer to 1, I have a value of 1. That's easy. This, there we go. Not so easy. Okay, what are limits? Limits are the y value that a function approaches as you get closer and closer to some predetermined x value. Now notice I didn't say the value of the function at that spot. I said the value that you get closer and closer to as you approach the limit. So, what is the limit as x approaches 2.5 of, let's call this function f of x? Say again? 1.5. 1.5. Now, that might bother some of you because there's no value at 1.5. There's a hole in the graph. It can't be 1.5. And this is the meat and potatoes, the heart of the idea for limits. It's the number that you get closer and closer to. It's not the number that it equals. So actually, my notation was sloppy here. It should be this. Okay, so then what's this? What happens if I come along from the positive side? What value do I approach? 1.5.
So it's the negative after the 2.5 when you're approaching from the left.
Correct. Okay, so instead of just sitting there quietly, I need some input now. Does this make sense? Okay.
A little.
Good. If I approach from the left or from the right, I approach the same number in this case, 1.5. So we're good to go. Right? Okay, good. Now let's look at this example here. Before we talk about this is the conceptual part of the problem. Approaching from the left and approaching from the right. What we didn't talk about yet was this. Okay, that's our third case now. The red one stipulates coming from the left. The blue one stipulates coming from the right. The black one makes no stipulation. It just asks you what's the limit at 2.5. What do you think the answer is? 1.5. Good. Okay? We're good. And we'll come back to this concept in a second. Now I wanted to look at an actual problem. I know what this function is. That function is that. Okay. Given the actual function, how do you solve the limit? Okay? Well, rule number one, always with limit problems, the first thing you do is plug and chug. By the way, you're going to need your calculators. Get those out, please. So I'm wondering, with this function, maybe this function is just like this squared function. And all I need to do is know the value at 4 for this guy to get the answer. And that's why we check plug and chug. So go ahead, plug and chug. Tell me what you get. Put 4 in for x and solve it. Okay, what do you get?
0.
Say again?
0.
No. Check that more carefully. What do you get? Why? Oh, what about the numerator though? Max, did you check the numerator?
Yeah.
What'd you get in the numerator?
It's also 0.
0. So we got 0 over 0. What do we know about 0 over 0? Very little, right. What we need to know about 0 over 0 is nichts sehr gut, meinen Schatzis. Okay, that is not good. We can't solve that problem. We don't have enough tools right now to talk about 0 over 0 again. So there's a problem. But we did what we needed to do in the first step. We plugged and chugged. It didn't work. So what do we do next? Any ideas? Factor the top and bottom. Go ahead, I'll wait. The fancy term for this is algebraic manipulation. Depending on your factoring skills, this could be easy or not so easy. Well, I guess technically that'd be right. No, it's not right. You need a 2x squared there. I see what you did. You put in quadratic formula solved and then just plugged the chug into there, right? Yeah. Anna, how's it factor? You have to talk loud.
Okay.
Say it loud, say it proud.
2x plus 7 times x minus 4. And then 3x plus 5 times x minus 4.
3x plus 5
Yeah,
times?
x minus 4.
Oh, well, look at that. What does that tell us? Oh, yeah, we change color. Whoosh, whoosh. Now, my picture is not 100% accurate. My scale's off a little bit. But you know from algebra 2, from pre-calc, that there's a hole at x equals 4. That's what caused the problems when we plugged and chugged. But now, that problem's gone bye-bye. So what do you do next? Rinse and repeat. Plug and chug again. See what you get. If you get 0 over 0 again, we got some problems. That can happen, by the way. It doesn't in this case, though. What do you get? Done. That's our limit. Plug and chug. If you get a numerical answer, you're good to go. If you don't, you try to algebraically manipulate. Plug and chug again. If you get an answer, you're good to go. If you don't, then we have some problems and we need to figure out a different way to approach the problem. Okay. So again, I feel like I'm beating a dead horse, but the limit is not the value of the function. It's the value that you're getting very close to. Okay, because this one has a hole at 4, it can't have a value. But it does have a limit as you get very, very close to 4. Now, this is calculus. So when I say very, very close, I'm not talking about 3.9. I'm not talking about 3.99. I'm talking about numbers like 3.99999999999. Very, very close. Infinitely close. Okay, so you have to get out of that realm of thinking in whole numbers or integers or even, 0.1. We're getting really tiny here. We good? That process of plug and chug, algebraically manipulate, plug and chug again, is going to be the most common way we solve limit problems. And what some of you are going to struggle with is the algebraic manipulation part of it. I think you're all pretty good with factoring, yes? You should be. However, we're going to get into some weird things. Like, I don't know, do you remember the word conjugate? Yeah? I know some of you just threw up in your mouth, right? But that's okay. We'll get you there. Okay, so we did that, blah, 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 factored 15/7. Awesome. Okay, so there's some notation again. This is a general form of limit notation. The limit as x approaches some value a of a function is equal to L. L is what's called the limit, L for limit. It's also the thing to remember, the y value of the function. The thing that you're taking the limit as approaches, this is the x value. It spits out a y value. What y value does the function approach as you get very, very close to that x value? And there's a picture, which you didn't need, but gives you another representation of what's going on using the general terminology there. All right, let's take a quick break. Warm in here. Gamble, you want to volunteer? Excellent. How many 5-year-olds can you beat up? Well, there are the rules. You're enclosed in an area approximately half the size of a soccer pitch, it's half of a soccer field. You can't use any weapons. No kicks to the groin. The children are relentless. They will continue to come at you. And once they're knocked out, they're done. Same is true for you. If you get knocked out, game over. How many do you think you can take? What's that? Yeah, but somebody will come by and drag them out of the way. 7. Excellent. So the rest of you come up with a number on how many you think you can beat. To answer your question, we have to answer some questions about you.
I feel like 25. 27.
All right, Campbell, you ready? Here we go. I'm going to ask you some questions. Is your body type obese, overweight, average, slim, or muscular? No judgment. We're okay with the answer. Average. Thank you. How long is your arm span? How tall are you? Okay, so normally your wingspan is the same as your height, so we'll go with over 3.5, right?
That's under.
Under, sorry. Over, right? How's your balance? Average balance. How high can you kick? I can't kick. I have a broken leg. I don't know. Not very high. I can barely kick 2 feet. Average or high? High. Very nice. That's going to help. How tall are you? You told me that already. There we go. How old are you? Do you have any experience in martial arts? None at all. In your lifetime, how many fights have you been in and how many have you won? 0 fights. No, it doesn't count. I'm talking like a real fight. Have you ever been trampled? No? Okay. Are you willing to fight dirty? Now we get a look into Campbell's personality. How do you feel about fighting children? It's wrong, you're neutral, you don't care, or you have mixed feelings? It's wrong. Oh. Would you pick up a child and use it as a weapon, Campbell? I thought that was against the rules. No, if he or she attacked me first, or yep. Okay. "20 children. Well done.
I'm gonna take this test.
Not bad. When you said 7, I knew that was too low, but I was thinking you'd be in like the low teens. But I think maybe the high kicking helped a little bit. Okay. Excellent. Thank you. Anybody else want to try it? Real quick. We have time. Patrick, you want to go?
Sure.
All right, hold on. Obese, overweight, average, slim, or muscular? Slim? Okay.
Just take your formula.
Over 1 meter? You got long arms, right?
Yeah.
How's your balance?
Excellent.
Excellent balance. Very nice. How high can you kick?
Pretty high.
Pretty high? Average or high?
High.
You can kick over 3 feet.
Yeah.
Okay. How tall are you?
6'3".
How old are you?
16.
Do you have any martial arts experience? How many fights have you won?
1.
One. You've been in one fight and you won it.
Yeah.
Okay. Have you ever been trampled?
No.
Will you fight dirty?
Sure.
How do you feel about fighting children?
Don't care.
Oh, good. A man of amoral character. Will you use a kid as a weapon?
Yes.
And what is your guess before I hit enter?
I'm doing this 25, but that's probably
45.
I'm guessing 30.
That's a good answer.
28. Yeah, at some point you're just going to get swarmed and run over. That's okay. Good job.
I just keep moving.
And it's kind of skewed when you go through it the second time because you start to process like the right answer to get a higher number. Like if you would have left your morals at home and been more willing to beat on a 5-year-old, you probably could have scored higher. 20 still is probably good. All right, so
I said that it wouldn't be 30.
let's talk about the notation first. I've got a function, sine of x over x. I'd like to know the limit as x approaches 0. What's the first thing you do? Plug and chug. What's the sign of 0? 0 over 0, no good. Can you algebraically manipulate that? No, do not cancel those x's. That would be silly. So what do we do now? You get out your graphing tool and you graph that puppy. Desmos or your calculator, graph sine x over x. If you're on your calculator, make sure you're in radians mode. Pregunta.
Didn't I do this last year? We were with
It's a good one.
I did this last year with us.
That function
Yeah.
or limit.
This one.
I don't. It's a pretty common example. In fact, there's a theorem based around it. I'll see what happens.
I changed myself to over 7 foot and a lot of
What is that?
Children. It doesn't even tell you. It's not the same. You take them all.
If you're like ever in that elementary school in that like scenario, you gotta go to the bathroom stall and then just like let them come in and like there's no value in it, so you gotta look at.
How long is Emily? Are you smarter than me?
I think it's 1 minute. No, I think it was not 1 hour.
Yeah.
I feel like it can't be.
Okay, so let's approach this from a couple different avenues. First of all, we tried to plug and chug, didn't work. Second of all, we graphed it. Oh, wait, no, I lied. Plug and chug didn't work. Can't algebraically manipulate it. So what do? We go to the graphing aspect of it. And when you graph it, if you did it on your calculator, you might want to zoom in. And when you zoom in, you get the answer right away, yes? What's the answer? 1. Correct. Now, another approach. Go to your table. And depending on how you have your table set, when you go to 0, you'll see an error. Right? But there are numbers above and below 0. Are you set? What's your table, delta table set?
It says x equals.
Okay, so you go by whole numbers. If you're going to use the table, if your table delta table, I should say, is set to whole numbers, you won't get a good picture. But if you go to your table set, do you know how to do that? By the way, it's above. Sorry, it's above the window button, and change your delta table to something like 0.1. It'll give you a better representation of what number you're getting close to when you get to 0. And so if you look, the numbers get closer from the top to 1 and from the bottom closer to 1? Okay, so there's a couple different ways to find that limit then. Now, the other question is, well, what if I don't have a graphic calculator? What if I don't have my iPad with Desmos on it? What do? It is possible that you don't have enough information to solve the problem. That will occur, and I'll talk about what you do in that case in a second. Okay. Any questions on those three approaches? Plug and chug, which pairs with algebraically manipulating, graphic, or look at a table. My preference is to look at the graph, but again, if you want to go to tables, that's okay too. Just be careful when you go to tables that don't use the integral values, use something much smaller so you get a better representation. Okay, what about this guy? That's a mother function, by the way. You should know what that looks like, yes? If you don't, grab it. Yes, correct. You got it, right? You're wearing a sweater today. You're the same. It looks like that. Okay, so I have the limit. The question is, what's the limit as x approaches 0 of 1 over x? But let me ask you a different question. What's the limit as x approaches 1 of this function? Suppose I change that to a 1. What's the answer? 1. Plug and chug. 1 over 1 is 1. What if x approaches 7?
1 over 7.
1 over 7. What if x approaches negative gabillion? Negative 1 over gabillion. Good. Okay. Now, what about 0 though?
Not possible.
Why not?
Because it's undefined.
Why?
You divide by 0.
Okay. So then what? Algebraically manipulate? You can't? All right, hold on. Let's try this then. What's that? What's the limit of that function as you approach 0 from the right-hand side, from the constant side?
Infinity.
Infinity. Why? Figure?
Because on the right side it goes towards infinity.
Good. It's asymptotic at the y-axis. It never takes that value, it gets closer and closer and closer. Everybody good with that? You can see it from the picture. Okay? What about this? Negative infinity. So now we're back to the three cases I had in the very beginning. From the right, from the left, and at the value. There is no limit at 0. There's a limit if you approach from the right and from the left, but at 0, we use the term DNE. Does not exist. Now, why doesn't it exist? Well, there's a nice fancy little theorem that explains that. And the theorem says, if you're going to have a limit at a value, the right-hand limit and the left-hand limit have to be the same. Okay? At 0, there is no limit. One side is infinity, the other side is negative infinity. Those obviously don't match, so no limit, DNE, at the point. If we go back, oh no, here it is. Nope, wrong way. Come on, Ricky, you got this. That guy, okay? We solved it without looking at the left and right hand side, but if you looked at the left hand side and the right hand side, they would both get very close to 15/17. The left hand limit matches the right hand limit. This one, not so much. So we get that fancy little thing. There's the calculus speak for you. And let me summarize this for you. Get rid of the blue so you can read it. If you're going to have a limit at a number A, that's only going to happen if these two things are true. We summarize that by saying the left-hand limit has to equal the right-hand limit in order for there to be a limit at the point A. What's more common is you're going to use that not being equal as a reason for why there's no limit. Okay, so a problem like that will show up and they'll say, what is the limit as x approaches 0, 1 over x? The answer is DNE, and then they will say, the College Board loves the phrase, justify your answer. The justification for your answer would simply be, the left-hand limit does not match the right-hand limit. Okay? How are we doing so far? Yes? We're good? Okay. Woo! All right, let's start with the red one. Some crazy function, similar to the other function we had, except different. What is the red answer? Oh, here, let's do this. You have 2 minutes with your table to come up with the answer to those 3 questions. Go.
X equals A. So as it approaches that, there's infinity, negative infinity, and then so wouldn't it just be infinity still? Because as you approach to the left and right, it's still infinity. Yeah. So they're just all because it goes up.
30 seconds.
That is not
So you put it from left, it goes up to infinity, you put it from right, it goes Did you get that one test where it was like there's 2 problems?
Time. Bia, what did you and your group get? Sorry, I couldn't hear you. Somebody was talking.
We said A, or we said that it doesn't exist, like asymptotes.
So none of them, all of them are DNE?
Just the last.
Just the last one. This one is DNE. This is... It's not that you're wrong, I just can't hear you.
Oh, okay. We said A. Number 1.
Oh, I got it. Okay. And this one?
A.
Okay. Small problem. Remember, the limit is the y value that you approach. This is the x value. So it's not A. Where we heard from? We heard from that group right there. Maria.
Yeah.
No, the other Maria. What is it? For which one? Both. All three. Ooh. Okay. Explain, please.
Because when you come from the left, the y arrow just keeps on increasing up, so it's infinity and same thing.
Hold. Everybody agree
Yeah.
with the red. Excellent. Back to you.
And then when you're coming from the right, it's the same thing.
Hold. Everybody good?
Yeah.
Hot diggity. Back to you.
And then the left and the right match. So just leaving it.
Excellent. Everybody agree?
Yeah.
Okay, good. Now we're going to get a little bit, no, easy there. Slow your roll there, sister. Okay. We're going to get a little nitpicky. I agree wholeheartedly with all 3 of those answers. You can see that the function keeps going up on both sides. However, we'll have to talk about this a little bit later in more detail, but either one of those answers is acceptable. Now, why? For one simple reason. I don't quite understand this, but I'm just passing on the news. The College Board sometimes likes to treat infinity as a concept, not a number. So a limit is looking for a numerical value. They would argue infinity isn't a number, it's a concept. For our purposes, I'll accept either answer for 3. Okay? In my brain, infinity is the more correcter answer. But if you want to go with DNE, you can. Say again?
Will the AP test take out of work?
they'll take either one begrudgingly most of the time. And if they don't, you won't know anyways. Ooh. Now things get real. This time you have 2.5 minutes. Go.
Wow. Alright. X is 0. Which one's that?
Yeah, so it's like 2.5.
Yeah, looks like 2.5.
It looks like here.
Next to 2 from the right is 1. Wait. No, there is no wait. Which 0? Which 2 is it?
I think it's the lower one.
That's.
It's coming from the 2, so I think it's
How does that work?
not 1.
It's 1,
Well,
right?
I mean, it's going from left to right.
But there are Y values that are in between 1 and 2.5. I mean, in between 1 and 3. They're just not added. So it's not like the limit isn't there.
I think it's 1.
I think it's 1. I'm so lost. Alright, number 3.
2, I'm going with 3.
That's what I'm thinking.
This one, the left side. Left side to, I don't know. Or would it be like the average in between them or something?
This one, I'm going to say 1 and 3.
There can be 2.
I don't know. There's 2 of them.
Okay, so I
Well, I have no idea.
wait, no.
For number 4, you mean?
Doesn't 2 and 3 have to be equal?
Yeah, for it to be even. I don't know. This is like a whack ass problem.
I think number 5 is 2.
Yeah, like for 5, it's 5.
2.
Well, what's the limit? No, you're not approaching like
2. Final answer.
which one? That's a 5. You're not going from the left to the right. It's exactly when X is 5. So wouldn't it be 1?
30 seconds.
What, is that a limit or is that like an actual value?
Bro, I don't know. I'm going to give my answer.
It ramps up pretty quick.
This is the top of the rack? Or?
No.
This is the bottom.
Where are we?
Getting closer.
Alright.
Oh,
It's about my limit. Hey, limit.
And time. Bryce, what do you got? Hold on. 1 is 2.5?
That's what I thought.
Yes?
Sure. Yeah.
Okay, we're going with it. Number 2? 1. Yes?
Yeah.
Okay. 3. 3? 3 is 3. How weird is that? Numbers. How about the green, number 4? DNE. Denis. Purple.
1.
It's a little bit higher than one.
Little bit higher than 1. What? 1.1? Oh, I didn't ask. 4, do you all agree?
Yeah.
What about 5? The purple one causes all kinds of
I'm gonna say.
problems for people.
I'll say yeah. Makes sense.
I'm going no.
Incorrectamundo.
I'm on.
The
Okay,
others are right.
so
Oh,
this,
said 1.1.
the purple one at that hole with
Wow,
a
I'm
point
guessing.
is the single most common mistake that people make. Let's go back to slide 1. What is a limit? It's the y value that the function approaches as you get closer to an x value. As I get closer to 5 along the function, what y value am I getting closer to?
2.
2. Good.
Oh.
Right. It doesn't matter that this dot is here. It wouldn't matter if that dot wasn't there. It's still the y value that you're getting closer and closer to. Let's talk about the green. Is everybody okay with the concept of that being DNE?
Yeah.
Because the red and the yellow, is anybody colorblind, by the way?
No.
Okay, good. Because the yellow and the red don't match, now we're back to the whole concept of left-hand limit not matching right-hand limit. And so therefore, number 4 is D and E. Okay? Good. Now, I'm doing a lot of graphical-based approaches to limits because I think that this helps you understand the concept. But eventually, we're going to have to grind out some algebra, like I did in the previous one with the rational function. Or like this one. This is going to be fun. What do you do first?
Or no, solve for
Plug and chug. You're all fairly bright. What happens when you plug and chug? 0 over 0. That's bad. So now what? Oh, you have to remember how to factor the difference of perfect cubes. You remember that, don't you? I didn't expect you to. That's why I threw this problem in there.
Thank you.
This will be something you want for your notes. All right, so I'm just gonna, while you're writing that down, I'm just gonna attack the problem then. By the way, notice there's no 2's in there. That's a common mistake when factoring the difference or sum of cubes. Number 2, if you factored it correctly, the trinomial is prime. Ooh, there's a lot of big words in that sentence. The trinomial, the one that has 3 terms in it, is prime. It can't be factored. But what does happen that makes me happier than can be than a little girl on her birthday? What? Did I do it wrong?
I think it's x squared plus x.
It is. Thank you. You want to fight? I mean, we can go right now if you want.
Would you rather fight him or 30 babies?
Babies or fifth grade? I don't want to fight a baby. That's no challenge. They just lay there and roll. Some of them can't even roll around. At least a fifth grader can be aggressive. I mean, the worst a baby can do is hit you with a rattle or something. Is that better? Okay. Good. Done.
Like get a good
So,
spot.
plug and chug, 0, 0, no good. Algebraic and manipulate. What? Yeah, then we did that. Then I plugged and chugged again. Hopefully I did my math correct. Because last time I checked, 1 plus 1 plus 1 is 3. What else could you have done? You could have slapped that bad boy into your graphing utility calculator thingy jobber and graph it and see what it approaches, or you put it in your calculator and look at the table. You have a couple different options. These are the type of problems I talked about when you're going to have to start doing some algebraic manipulation. Okay, and a lot of it is going to be refreshing some algebra skills, like how to work with a conjugate, how to factor quadratics, how to, in this case, factor a cubic. We good? Oh, I don't know. That's up to you. There is one thing I wanted to talk about. By the way, I summarized your process for finding limits. Plug and chug, algebraic, look at the graph, gas, pray, plug and chug again. Okay. One quick thing. Let's go back to this function. We did this already. We said that that is undefined, right? Left-hand limit didn't match the right-hand limit. Some of the problems we're going to deal with, however, take a different approach to that problem. So, for instance, what I would like to talk about is what happens when you have a number over a variable and that variable approaches 0? What happens when the denominator of a fraction gets very, very close to 0? What happens to the fraction? Say again? How so? It just goes nuclear? Okay. Let's try this question. What happens when the denominator of a fraction gets very, very big? So let's suppose A is 7 and B is getting bigger and bigger and bigger and bigger. What happens to the fraction? What does it get close to?
0.
Are you raising your hand? Okay. Anybody? Come on.
0. 0.
Why?
Because if the denominator is like significantly larger than the numerator, it's worthless.
Oh, sorry. Did that wrong. That's what I wanted. As B gets very, very big, the denominator gets very, very big, but the fraction gets smaller and smaller and smaller and eventually approaches 0. That idea of plugging infinity into the bottom of a fraction, or looking at what happens at the bottom of a fraction when it gets very close to 0, is going to become more common. As the denominator gets closer to 0, we can't have 0 in the denominator, but as it gets closer, what happens to the fraction? Well, we take something like 1/2, 1 over 1, 1 over 0.5, 1 over 0.1. What's happening to that value? It's getting larger. And as it gets closer to 0, what's going to happen to the entire value of the fraction? It's going to go to infinity. So this limit as x approaches 0 is infinity. Okay? We'll play with that a little bit more. Questions? All right.
How much of that share on that?
Some of the homework problems are conceptual, understanding and demonstrating that you know what this limit idea is. The others are pure algebraic, and you need to get in there and get your hands dirty. I use that phrase all the time. Try some different things. That's why you have an eraser, or you're on an iPad that can erase. Okay? Try some different things, look at some different approaches to problems. If you forget about all the other silly stuff in there, plug and chug, algebraically manipulate, plug and chug. Okay. I would leave the graphing to the last resort or as a checking method. So you get an ugly fraction or an ugly function that you don't know what it looks like, try to find the limit algebraically. If you get an answer and you want to check to make sure it's correct, you can either check the answer key or put it into your calculator and look at the picture. I would recommend if you want to check it, use your calculator because it's good practice. Okay? We good? Excellent.